when you collect data, it's going to have either a strong or weak positive correlation, or a strong or weak negative correlation, or maybe no correlation at all. So in this case, you can see the data is collected and it has a strong trend. It's going this way. And you can see that the distance from any one of these points to the best fit line is very short. That's what it means to have a strong positive correlation. It's that the residuals are all very small. The residual is the distance from any point to the line of best fit. A weak positive correlation, we could fit a line through here, and again, the best fit line would probably be the one that has about 50% of the points above and below the line. That best fit line, you can see in this example with a weak positive correlation, the distance grows. Any individual point is going to have a larger distance to travel to get to the best fit line. That's what a weak positive correlation would look like. A strong negative correlation looks the same. You can fit a nice best fit line in here, and each of the residuals, the distance from the point to the line, would be very small. But a weak negative correlation, what that means is that each of these residuals will be a little bit longer. The distance from any individual point to the line is longer, and so the residual is greater. So you can see that the negative here doesn't mean there's no correlation. It means that the slope of the line is negative. That's really all we're saying here. So when there is no correlation, it looks like this. There's simply no line I could put here that would indicate the direction of movement of this data. It doesn't have any particular direction, and so none of these best fit lines would predict the next point on the graph. Okay, moving on. So let's take a look at these individual graphs and let's choose which one is the best fit. So the data seems to me to be moving in this direction. It's moving down and to the right, just slightly. The graph that's going to, or the line that's going to do the best job at predicting the data is going to be the one that has about 50% of the dots above and 50% of the dots below. So this is the best fit right here for this data. Let's look again at this one. As you look at this data, what you're going to see is that they generally are moving down and to the right. So this is a terrible fit for this data, right? Because the data overall is moving down and to the right, and that's pointed in the opposite direction. We want the residuals to be as small as possible. So if you're trying to decide between this one and this one, right, what we're doing is we're looking at this point way out here and going, wow, that's a long distance to the line. Whereas over here, with it being shifted, that's a very short distance. So you see also that this graph puts about 50% of the points above and below. That's going to be the best fit right here. All right. So now we're going to try to write the equation of the line of best fit. So here they've already put the best fit on the line for you, and we're going to try to write the equation. So let's start with y equals mx plus b. And what we're going to do is simply record the intercept. Here's the intercept at 1. So we're going to write that down. We have mx plus 1 now. So you can see what we still need is the slope. How do you calculate slope? Slope is the difference in the y's and the difference in the x's for two different points. So let's use the points that they've marked. Here's this one point right here. They've marked it out for you. That point is 0, 1. And then this point, the coordinates are 9 and 7. Or rather 7, 9. Okay, so let's mark these like this. This is going to be y1, or rather, I'm going to call it x2 and y2 like that. This is going to be x1 and y1, and I'm going to put them into this expression. Okay, so it's going to be like this: 9 minus 1. Okay, so 9 minus 1. And then I'm going to go and get the x values and put them on the bottom. 7 minus 0, like that. So I get, on the top I get 8, and on the bottom I get 7. So the slope is 8/7. So I'm going to put that number into the equation. It's going to be like this: y equals 8 over 7x plus 1. That's the equation of the best fit line. Now let's say I needed to predict. See how this graph only goes to 10? Well, let's say I wanted to predict what would happen at 49. Okay, so let's say f of 49. What is that? Well, that would be 8/7 times 49 plus 1. What I did is I put this value in for the value of x. And so as we solve this, we'll see that this is, that's 49 and 7 go into each other 7 times. So it's really 8 times 7. And 8 times 7, just take a look at your graphing calculator. 8 times 7, that's equal to 56. Okay, so this is 56 plus 1. So the output of the function is 57. So f of 49 is 57. The point on the graph that we would plot would be 49, 57. That's the point on the graph that we would plot. Okay, let's try a more difficult one. This one does not have a y-intercept. And so what we have to do is we cannot use the y equals mx plus b format because there's no b. I can't see the intercept. It's not there. So instead, what I'm going to do is I'm going to start just by finding the slope, just like we did last time. So let's focus in on the slope. So slope would be y2 minus y1 over x2 minus x1. Let's mark these points out. This is going to be 7 and 4. So 4, 7. This is going to be, we'll call this x2 and y2. This point right here, this is 8 and 0. We'll call that x1 and y1. So let's plug them into the equation. So I'm going to take the y's. It's going to be 7 minus 0. 7 minus 0. And then I'm going to do the x's on the bottom. 4 minus 8. And let's do the subtraction. So 7 minus 4 on the bottom. So negative 7/4 is your slope. Now, because I don't have an intercept, I have to use the point slope form. Y minus y1 equals m times x minus x1. Okay, so I'm going to put my slope in. Here's my slope. I'm going to put that in right here. Negative 7/4 of x minus x1. And now I'm going to go back and just pick one of those points that I just had, right? Let's use this one. 8 and 0. So let's put that in. That would be y minus 0. 7/4 of x minus 8. Now, I don't have to write the minus 0, so it becomes y equals negative 7/4 of x minus 8. And then the only thing that is different from this form, the slope-intercept form, and this is the parentheses. So we're going to get rid of them, okay? So let's get rid of the parentheses. This is how we'll do it. We'll distribute the negative 7/4 to everything inside the parentheses. So it would be negative 7/4 x, and then negative 7/4 times negative 8 looks like this. Let's just take a little extra room. Negative 7/4 times negative 8. Imagine that the 8 has a 1 on the bottom. And what we're going to do is multiply straight across. So that's going to be positive 56 on top. Positive 56 on top. And 4 on the bottom. And 56 does go into 4. Okay, so 56, if we divide that by 4, we get 14. So this number is actually positive 14. So that's what we write right here. This would be positive 14. Here's your equation.